Luxury supercars flying down the road define the popular image of Germany. Yet the Autobahn is a greater source of pride, where the idea of a speed limit almost does not exist. How does Germany operate one of the safest high-speed systems on the planet? American engineers often wonder about this. The road acts as an engineered structure, but this is just the beginning. It is not just paved over the soil, this network is advanced. At first glance, it looks like an ordinary stretch of pavement, but in reality, it relies on a different philosophy. One can notice the stability of the surface, because special standards in cutting-edge technology make the Autobahn the gold standard of modern transportation engineering. It is visible how it withstands pressure. The construction demands absolute precision. It gets more complex further on. Thus, the secrets of the design await discovery. 357,000 square kilometers is the total area Germany covers. Why is the highway density here 7 times higher than in the United States? The country is less than half the size of the state of Texas. But unlike nations that simply lay a layer of asphalt, Germany approaches road building with a completely different philosophy. A road must be built, not merely paved. More than 8,000 miles of Autobahn stretch across the land. But this is just the beginning. One can notice how the structure is built around 4 distinct key layers. At first glance, it appears to be a simple surface, but in reality, the highway consists of complex tiers. The foundation begins with a compacted subgrade, followed by a stabilized sub-base layer to distribute the weight. A load-bearing base course sits above, topped by a high-performance asphalt surface. It is visible how this multi-layer structure prevents cracks, deformation, or rutting. Even when cars travel at 300 kilometers per hour, the surface holds firm. It gets more complex further on. Germany developed advanced polymer-modified asphalts as the real key to this longevity, capable of withstanding summer temperatures up to 70 degrees. One can see that the material remains flexible in winter, resisting freeze-thaw cracking without failure. These strict engineering standards ensure that high speed is safely supported by world-class technology. 25 to 35 tons of impact force hit the ground with every rotation of the roller's drum. This level of power is safely supported by world-class construction technology. Why does the process begin long before the first tree is felled? It might seem like the forest is just waiting for the bulldozers. But without detailed geological surveys and terrain analysis, the heavy machinery would be operating blindly. Technical teams undergo a long preparation phase involving environmental checks and detailed planning. These calculations determine exactly where the road will run and how thick each structural layer needs to be. But this is just the beginning, because specific soil stabilization methods must be selected for every individual section before work starts. Official permission to begin actual on-site construction is granted only after all data is fully reviewed and approved. When the site is officially handed over, the landscape changes drastically. Crews immediately clear trees, vegetation, and topsoil to expose the original ground underneath. At first glance, leaving organic material seems harmless, but in reality, it causes settlement and instability in the road foundation later on. Once the area is cleared, the process of cutting and filling the terrain begins. One can notice how high hills are lowered and low areas are filled in to match the designed elevation. The blade of the bulldozer cuts through the earth, ensuring a continuous, smooth roadway without breaks or uneven levels. It gets more complex further on. Heavy vibratory rollers move in to compact the soil, making the ground level and stable. One can observe how the crews usually make 6 to 12 passes over every meter depending on the soil type and moisture level. The goal is to bring the soil up to the standard Proctor density, creating a surface strong enough to carry the huge loads of European trucks. Next, heavy trucks bring in crushed stone, unloading it section by section along the future route. Right after that, a grading machine spreads the stone evenly, covering the entire surface. Transition to the next level. Water trucks spray a thin layer of moisture that darkens the gray stone to help the particles bond better during compaction. A bulldozer then reshapes the layer, making sure the thickness and flatness meet the required standards. Finally, a large vibratory roller compacts the material through multiple passes to create a strong upper base. This crushed stone layer acts as the load-bearing foundation, distributing vehicle pressure into the soil below. The concrete base layer is now ready to be poured as heavy mixer trucks enter the mix. 40 centimeters of solid concrete. This is the exact thickness of the layer that will form the foundation of the future high-speed highway. Trucks carrying pre-mixed cement with precise consistency begin entering the site. Why is the mixture unloaded onto the ground before reaching the paver? At first glance, direct pouring seems faster, but in reality, this intermediate step allows the excavator to control the feed rate to prevent surges that could disrupt the mechanism. The drum lifts to deposit fresh concrete onto white protective sheets, which prevent moisture loss and keep the underlying surface clean. One can observe how the excavator uses its large bucket to scoop each batch and transfer it directly into the hopper. But this is just the beginning. Continuous loading ensures the slip-form paver receives a steady supply without a single second of interruption. Inside the unit, an internal auger system spreads the material evenly across the full width of the road. High-frequency vibrators operate continuously to compact the concrete, forcing air bubbles to the surface to ensure uniform density. A shaping mold at the rear then presses the mixture to exact design dimensions, strictly maintaining thickness and cross-section. The entire process is guided by a laser-controlled system, guaranteeing precise smoothness and slope down to the millimeter. With such continuous operation, the complex mechanism builds dozens of meters of roadway in just a few hours. However, structural integrity requires reinforcement. Steel dowel bars are placed into the loading tray above the machine to be inserted into the fresh concrete. It gets more complex further on. The mechanical system automatically pushes each bar into the concrete at the correct depth, spacing, and position. These steel elements are crucial as they increase durability and transfer loads between adjacent slabs, allowing the roadway to behave as a continuous structure. One can watch as long finishing arms sweep across the surface immediately after shaping. These blades smooth and lightly compress the top layer to remove waves and achieve the necessary finish. A specialized spraying truck applies a layer of curing compound when the surface begins to set. One can notice how the paraffin-based or acrylic liquid forms a thin film over the wet concrete. This barrier slows water evaporation, helping the material reach its optimal strength without cracking. And this is not the limit. After about 30 to 60 minutes, specialized brushing machines arrive to texture the pavement. One can see the high-speed rotating brushes lightly sweep the top layer, creating fine grooves that improve tire grip. The process removes excess cement dust, leaving a clean surface for the final touch. A specialized cutter creates expansion joints at design intervals to protect the structure. The concrete pavement is left to cure for several days before the next step of asphalt paving. 160 degrees Celsius is the critical temperature at which the hot asphalt arrives at the paving site. Dump trucks back up to the machinery and unload the steaming mixture directly into the paver's large hopper. One can notice the heat waves shimmering in the air as the black material slides down. This stage represents the most important step in building a modern highway. But this is just the beginning. The conveyor system and augers instantly move the material toward the back. Why is the screed on these modern European and German machines considered the source of the real magic? To the observer, it simply looks like a leveling blade dragging behind. This unit creates a dense, stable structure by achieving 85 to 92% compaction, while the asphalt remains extremely hot. The mix spreads evenly across the full width of the road before the screed passes over it. It is visible how the augers rotate continuously to distribute the material without gaps. The screed acts as a vibrating, tamping, and pressing unit all at once. It shapes, compresses, and smooths the layer in a single efficient pass. It gets more complex further on. Because the surface course, or stone mastic asphalt, is only 2 to 3 centimeters thick, it cools very quickly. At first glance, using traditional vibratory rollers seems like a standard solution, but in reality, they can cause cracks or ripples on such a thin layer. The automatic screed ensures the road surface stays perfectly smooth and uniform along the entire stretch without these defects. This method proves especially effective where thermal management is difficult. The Vogel pavers from the Vergen Group are well regarded for their precision and material efficiency in this specific task. Today, high-end asphalt pavers handle more than half of the compaction work inside the machine itself. This advanced equipment reduces the need for subsequent roller work by 70 to 80% compared to older methods. In the past, the process required multiple rollers, including vibratory, static, and pneumatic types. Transition to the next level. A light steel roller may make one final pass to finish the surface. Many projects skip this step entirely because the mat already meets standards straight out of the machine. Thanks to this new technology, asphalt paving is faster and ensures long-lasting highway quality. The consistency of the road improves significantly for years of operation. The asphalt cools and hardens, ready for the next phase of the infrastructure project. 180 to 200 degrees Celsius is the temperature the thermoplastic paint must reach to ensure maximum adhesion to the asphalt surface. Once the pavement has cooled and achieved full stability, the crew begins the precise layout process using laser measuring tools or guide strings. They determine the exact position of each lane divider, stop line, and directional marking before the specialized striping machine begins its work. As the equipment moves, its spray head applies the hot material, creating lines with the precise thickness and width required for highway standards. But this is just the beginning. Why are tiny glass beads dropped onto the fresh paint immediately after spraying? To the observer, this might look like a simple texture addition. However, these spheres are necessary to reflect car headlights at night, significantly improving visibility and safety. One can notice how the markings harden and bond firmly to the pavement after just a few minutes of cooling. The final step before completing the highway involves installing concrete barriers, which are usually precast in a factory setting. Workers pour the mixture into high-precision steel molds to ensure all dimensions and angles remain perfectly consistent. After pouring, vibrating tables compact the concrete, creating a smooth surface and increasing strength. At first glance, casting a block seems like a routine operation, but in reality, this vibration is critical to eliminate air pockets and ensure durability. Once the concrete reaches full hardness, each barrier is removed from the mold, quality checked, and numbered in the order of installation. It gets more complex further on. Cranes or specialized forklifts place the concrete segments exactly where the plans specify at the construction site. Workers then secure them together using steel pins or bonding adhesive to form a continuous and stable barrier line. This precast installation method speeds up construction, reduces road closure time, and improves safety during maintenance. One can observe how the individual segments align to form a solid wall along the roadway. Therefore, the engineering team conducts a final inspection of the entire highway infrastructure. They check road smoothness, drainage performance, surface traction, and the structural quality of every section. Each component is approved only when it fully meets all safety and technical standards. Thus, the highway receives the green light to open for use. 8 to 15 years is the maximum duration a highway surface typically endures. before requiring comprehensive restoration. Day after day, heavy truckloads and the relentless cycle of freezing and heating degrade the asphalt structure. The surface gradually loses its grip and smoothness, demanding immediate recycling to restore its structural integrity. Only when the road meets all technical safety standards is it allowed to open for use. But this is just the beginning of the heavy industrial work. The restoration process begins with the arrival of massive milling machines. Why do engineers remove only the top 2 to 10 centimeters of the pavement? At first sight, the damage often appears to penetrate deeper into the foundation. But keeping the underlying basin structure intact allows the road to be renewed without being rebuilt from scratch, which significantly shortens construction time. One can notice how the milling machine's rotating drum grinds the old asphalt into small, manageable pieces. The debris travels up a steep conveyor belt and falls into the bed of a truck following directly behind. This milled material, known technically as reclaimed asphalt pavement, is transported to a recycling plant for processing. There, the raw stream goes through a complex screening system. It gets more complex further on. Automated screens sort the material by particle size, separating usable asphalt from waste. Because the reclaimed pavement can have varying levels of aging, it must be cleaned of soil, oversized stones, and metal impurities. Usable particles are then blended into uniform batches to strictly control quality. This ensures that the recycled mix will perform just as well as newly produced material. At first glance, mixing old oxidized asphalt seems simple, but in reality, it requires the precise addition of a rejuvenator to restore elasticity. The material is heated gradually to prevent burning the aged binder, then combined with fresh aggregates and hot binder according to a pre-calculated formula. Modern plants can incorporate 30 to 60% reclaimed content without losing performance. And this is not the limit of efficiency. This method significantly lowers overall construction costs and reduces carbon dioxide emissions. Back on the road, the surface is thoroughly cleaned of dust and debris to ensure maximum bonding. In this modern process, a single machine performs 2 critical tasks at once as it moves forward. One can see the front nozzles spraying a thin layer of tack coat, using liquid asphalt or emulsion to act as a glue. Right behind the spray bar, the same machine immediately places the recycled asphalt mix onto the prepared surface without any waiting time. The paver spreads the hot material to the design thickness, while the screed vibrates continuously to form a smooth, uniform layer. It is visible how vibrating and static rollers compress the mixture to the required density, eliminating the risk of rutting or cracking. The roadway is soon ready to be reopened for public use. One continuous cycle ensures the road surface returns to a pristine state. The asphalt now withstands heavy loads, performing just like new. One can notice how traffic resumes smooth flow on the rehabilitated section. But this is just the beginning. Why link building, maintaining, and recycling? At first glance, they seem distinct. But in reality, German engineering unifies them to ensure the system functions reliably. The highway is now ready for operation,